dividing rational expressions. So really similar to multiplying, there's actually just one more step that goes into them beyond multiplication. So if I have 3pq divided by pq over 6p squared q squared. So remember when we divide two fractions, just like if they're numbers, that's the same thing as the first multiplied by the reciprocal of the second, or flipping it. Literally, that's the only additional step. Now we're just at a multiplication of two rationals. So we're going to see, do they need to be factored? Well, these are already actually factored, so we just need to cancel. So 3 reduces to a 6, that becomes a 2. 1p cancels here, 1q cancels here. Just cancel the second p and the second q. So now this whole thing becomes 2p squared q. Say, for example, that I was given 3k squared plus 5k minus 2 over 9k squared minus 1 divided by 4k squared plus 8k over k squared minus 7k. So remember, keep the first fraction the same and multiply by the reciprocal of the second fraction. So first fraction the same, multiply, flipping, here's the denominator flipped to the numerator, numerator flipped to the denominator. So now we need to factor. Well, this top one factors to become 3k minus 1, k plus 2, difference of squares, so I get 3k minus 1, 3k plus 1. K squared minus 7k pulls out a common factor of k. 4k squared plus 8k, I can pull out 4k, and I'm left with k plus 2. Canceling what's common, k cancels, 3k minus 1 cancels, k plus 2 cancels, and I'm left with k minus 7 all over 4, 3k plus 1. So dividing is flipped by the times the reciprocal of the second fraction, and then we just had to multiply. So factor each piece of the fractions, cancel out what you can, write in lowest terms.